Okay, welcome to session 5 in a series of webinars. In this particular session, we're going to look at Metrology 4 and basic programming. Before we do that, just a little bit of information about what you're seeing here. So we have a PGI Nova system. This is capable of surface finish and form measurement. It's a 200mm traverse. We have a 20mm gauge, a dual bias gauge and stylus, so we have a double tip stylus. You'll see a little bit more of that during the programming. We also have a 450mm column, and you can see here a Y stage and also a rotary stage. And on the rotary stage we have some test parts, and one of those parts we're going to show how to program around, so it's quite a useful component. We're going to use Metrology 4 software. Metrology 4 software is, one of its unique features is its capability of giving you a virtual display. The virtual display is an exact replica of the real instrument. And what that means is we have a coordinate system and we can program using the virtual display. So today what we're going to do is use a CAD model. The CAD model we're going to load into the software. So if I go to File, I can import a part. And this particular part is a CAD model of the test pieces that you see on the rotary stage here. So I'm going to load test pieces. It takes a few seconds to load because it's a fairly complicated CAD model. And you can see now, once the part is loaded, we have our CAD model. So what I'm going to do now is show you how we program around it. But before we do that, the problem with the CAD model is we've got to make sure that that's exactly in line with the real part. So the way we do that is we have a part configurator. So the part configurator allows us to translate or move in X, Y, and Z, and also rotary, in order to line the CAD model up with the real part. So I'm going to move this on the screen here. I'm just going to take a note of where I am currently. And you can see that as I hit this arrow here, I'm moving in X and translating. I can also move the model around in Z. And if I just put it back to where I know it should be, you can see that we can actually move the CAD model so that it's representative of where it is on the system. The other thing with the CAD model, of course, is that this is on a rotary stage and a Y stage, so if I choose to move the rotary stage, for example, we're just going to move to 357 degrees, if I turn that to 357 degrees, you can see the CAD model rotates, and so does the real part. What that means is that now we can program around the actual CAD model and not have to look at the real part. And if you look at this particular component here, it's a simulation of an internal bore. What we've done is we've cut away the bore so that we can see inside, and obviously it's very good for demonstration purposes. But in reality, normally what would happen is you wouldn't be able to see inside there and you would be going down a blind hole. Well, that's not the case because we've got a CAD model. So what I'm going to do is I'm just going to show you an example. So I'm going to set my lift lower to 0, so you'll see the stylus raise to its 0 position. And all I'm going to do is just look at a side or front view, front elevation of the CAD model, and I'm going to show you how I can use the CAD model to move around the part. So for example, if I move over using the joystick, you'll see that I can move on to the top of the model. If I let go of the lift lower, it'll touch the part, and you're seeing not only the CAD model touch the part, but you'll see it happening on the real part. So as you can see, I can use the CAD model for programming. So what I'm going to do now is just show you the benefits of going inside the bore. So I'm just going to lift the lift lower again to 0. And I'm going to use my CAD model to go inside the bore. And I don't even have to look at the part because I know that the coordinates match each other. So it's a very useful feature, especially when you're going down a blind hole. So we're moving inside the part, and if I wanted to stop on that edge there, you can see I've got there exactly. So that's where I am in the CAD model, and this is where I am in the real part. So I'm just going to come out of there, and we'll go on to programming. Okay, what we'll do is we'll look at a 3D view of the instrument. We'll just zoom out a little bit, and I'm just going to take the stylus and move it upwards. Let's go a little bit faster. We'll change the speeds. And we'll move that up a little bit here, and I'm just going to move X over slightly. All right. So what I'm going to do now is just bring up the program menu. So if I go along the top level menu here, you can see the programming editor. If you hover over with your mouse, you can see it describes with the tooltip what that programming editor is. If I click on it, I can set up my workspace accordingly. So what you can do is you can pin or unpin the controls for the instrument so they're not in the way, or you can take the program editor, pin it, and then you use up half of the screen in this instance for your programming. There is a dual screen, so you can drag this out and put it on another screen. In this case, because we're trying to demonstrate, I've got to do it all on one screen, so I'm just going to put that back to the side there and pin it as we have it before. What I'm going to do now is just go through the menu of the program editor. So initially there is no program, and you can see there is options such as new, open, an existing program, stop when we do have a program, the record button, and tortoise mode, which we'll go through at the end here. So the first thing I'm going to do is click on new. So when I click on new, you'll see various icons appear. First of all, you have your top level ribbon with all your functions on there, and we've already gone through a few of them, but you see some extra ones now, such as if I hover over the green arrow there, you can see that it runs the program. And then there are various things like run from step, run a number of times. We have our stop program and record, as you saw before. So the other thing we've got is a properties menu. I'm going to write a program here. What I could do is I could click on it and give it a name, test program, for example, and I can say who the author is and when it was modified and so on. So author is me, and if I save that, it'll save that with this particular program. We're not going to name the program yet. We'll write the program and then we'll save it as a given name. So inside this area here is where you'll start to see the steps of the program appear. And on the right hand side is what we call our toolbox. Now the toolbox has all the various functions and features that enable you to actually write a program offline or online. And I'll just give you a quick example. We might want to put a comment on the programming. A comment has no purpose other than to give the programmer some information about this program. So I'm going to drag this over into the script area, and then I'm going to put a comment. This is a test program. And you can see there's step 1 in our program, and it's a test program. Down at the bottom we have also the ability to capture errors. So if there are any programming errors, they'll appear at the bottom and they'll tell you which line number and how to correct them. What I'm going to do now is press record mode and record the steps. So the first step we want to record is to home the instrument, our start position. So call up the instrument control, and I'm going to say, okay, I want to move to 150 millimeters in X. I'm going to move 250 millimeters in Z, We'll have this at 16.67. We're going to leave the rotary stage in its position as it is, and we'll have the lift lower at 0. And then as soon as we've done that, I'm going to press the vectored move. What that will happen is all the axes will move at the same time, and because we're recording, you'll see step number 2 appear in the programming screen. So here you can see the vectored move and its positions. Now if at any time you make a mistake, it's very simple. You can turn off record, and now you're in edit mode. And if you want to increase the speed of something, for example, we might want to make the X move faster, we can set that to 13 and it'll move faster. And of course we can use the collapse and the expand buttons to look at the individual entries. So if I just collapse for now, we have our vectored move. If we want, we could add a comment in here. We can slot it in between the information about the program and the actual move and say this is the home step. Right, what I'm going to do now is I want to move and measure inside this ball. So I'm not in record mode at the moment. I'm just going to turn this around so that I can see inside this ball. And I'm going to create points that I want to move to and measure from. So the way to do this is put it back into record mode. I'm going to click at point just on the screen here. I'm going to create another point just here inside the ball. And I'm going to create another point just outside the ball, and then another one inside the ball. When I've finished that, you can see that it's recorded all of those points. Now the best way of programming this is to actually program it in the order in which you're going to move to them. So point number 1, point 2, point 3 and point 4. Right, now I've created the points, I can use a very useful facility that allows me to move to those points. And what's going to happen is if I right click, it asks me, do you want to move in X and Z? And I say yes, I want to move in X and Z. Click on it, it'll record that move, and it's going to move to that first point. Okay, we're now going to move into the internal ball. In this case, we're just going to move in X, so move to position. Again, you can see it's recorded that move. Now we're going in at 5 millimeters per second. We can actually increase that speed later if we're happy. Next move is to move to instrument control and just park the lift lower so that we can make a measurement. And what we're going to do is select 2D measurement. We'll call this lower profile. And what we can do is actually start a measurement immediate, or we can actually start from a given point. You can see that if I select point, we've got a list of points. And this is point number 2, so we could actually start at point number 2. In this case, I'm just going to measure it immediate. And instead of measuring to a given point, we can actually measure a length. So I'm going to measure a length, and we're going to make it a 60 mm measurement. We'll go at 2 millimeters per second. We can also going to create a new document. So what's going to happen is this measurement is going to go into a new document, and we'll show you that later on. So if I press OK, I'm still in record, so you'll see all of those settings have been recorded, and now we're starting to measure. So we now have our measurement. I'm just going to unpin the program editor and just show you that I can fade out this CAD image so you can actually see the profile that's just been measured. Okay, so there you can see the profile that was measured. So a nice facility, we can fade out the instrument so we can just see the profile and the points. What I'm going to do now, we're still in program mode. I'm going to pin that again. Still in record mode, I should say. I'm going to collapse that. And what I'm going to do now is just lift the lift lower again. So we want that at 0 millimeters. So we'll lift the lift lower. And I'm just going to move out the bore to a safe, clear position. So we'll move in X back to the start position here. Now, that's the lower profile, and you notice the little green arrow here. That green arrow is telling us we're in normal bias, so we're measuring a surface that's below the tip. But this is a dual bias gauge, so what we're going to do is we're going to go to change the bias to reverse bias. We still want the lift lower to be in 0 when we're finished, so if I press OK, what will happen is the instrument has moved to reverse bias, and we'll put the lift lower back on. And now we're in reverse bias. Now I'm just going to move the stylus down a little bit so I can show you a feature here. Before we were moving around with this tip, the lower tip. Now we're moving around with the upper tip. So if I want to move to this point, click on it, and I can say move in X and then Z, and it'll move to that position. And again, we've recorded that move. And now I'm going to move inside the bore again to the inner position. And again, I'm just going to use X because that's all we need. And you can see, again, it's moving at 5 millimeters per second into the bore. And again, we're ready to measure. So what we're going to do now is I'm going to release the lift lower again. So we're going to park the lift lower. And now we're going to measure that upper area. But again, go to 2D measurement, and we'll call this upper profile. Again, this display analysis option means that when it's finished measuring, it'll actually display in the analysis view. So I'm going to select that this time. Again, we'll measure immediate, and we'll have a 60 millimeter length, and again we'll go with the same speed. But this time I'm going to append the this measurement to a document that already exists, and you'll see both measurements appear in the same document. So if I press OK, we're going to take another measurement. Remember, as soon as this finishes, you will see you'll switch from the instrument interface to the analysis interface. And here you have the two profiles. Now we'll come back to those later. They both appear the same way up, but the air-metal relationship is different. And we're going to come back and create a document in a moment. First I'm going to go back to the instrument view. Again, I'm going to unpin the program editor, and I'm going to fade out the CAD model so that you can see that we have now two measurements of that internal bore. Okay, now I'll bring back the program editor. We're still in program mode. If I pin that again, we have now the instrument view. I'm just going to set our instrument control again, lift lower to 0. Again, it's recorded that as step 19. And I'm going to finally move to this position. Now, one thing I haven't shown you here is we can do things like cut and paste steps. Now, I'd like this to finish in the same position in which we started. That means I've got to take it out of reverse bias mode and put it into normal bias. So I'm going to put it into normal bias. I'm going to leave the lift lower at 0. And you'll see the green arrow change in the top left-hand corner here. And what I'm going to do is I'm going to take it off record mode, because all I want to do is repeat the step where we have a vectored move. So I'm going to click on the vectored move. I'm in edit mode now. So what I do is I click on the vectored move, and I've got these options to copy. If I copy that, I can move to the end of the program, and I can paste that in there. And you can see it's gone actually as step 21. I want it to step 22, so I'm going to just move it to the end there. Now, another feature that you can use here is we can actually run that step. So if I want to return, right click, run from here, and it's just going to run that step. So if I run from there, it's going to return the instrument to its original position. And if I zoom out, you'll see there we have it. So that's our program complete. There are various other things we can do, but the first thing we have to do is create a document. So that's what we're going to do now. We're going to create a document, and then we're going to apply that document in our program. So I'm going to select both the lower and upper profile with my mouse. I'm going to go to Studies, and you can see we have contour analysis. If I click on contour analysis, I get a contour screen here, and you can see that there is the relationship and the coordinates for both profiles, so we haven't lost that relationship. If I go to full screen, I'm going to create a document. Now the way I'm going to do it very quickly, this isn't really, this demonstration is more about programming, but we'll show you a little bit of contour. So what I'm going to do is create a best fit line all the way through these parts here. So we're going to create them all the way along, just very quickly, just to demonstrate. And again, with the lower profile, we'll create best fit lines. There's an option here to allow us to auto connect all the elements, so I'm going to connect those, and now we have all our best fit lines. What I'm going to do is just create some dimensions, some basic dimensions, so we can have, for example, a distance. Let's have a distance from there to there, or a diameter. We can have a diameter from here to here. If you make a mistake, which I just have, all you have to do is undo. Press the undo button. That's also available in the programming button as well. What I'm going to do is just a distance. Let's say we'll have a distance from here to here, and a distance from, let's say, here to here. And of course we can do other things like angles, just here. Let's have the angle from here to here, and so on. Okay, the other thing that we can do is we can do some surface finish. So what I'm going to do is just look at the surface finish. So I'm going to look at the residual error of the best fit line to the profile. So I just click on this option here and click there, and we can see our profile there. If I click into this, you can see I have the option to select some parameters, and I'm going to ask for roughness parameters. So we'll have ISO 4287, roughness profile, and we'll just ask for the RA and the RZ. And we're going to use a filter. Let's do a 2.5 micron filter, and then just press OK. And there we have our result, the surface finish. And again, we can do that again somewhere else. So let's just do a surface finish result here. And you can see again we have the surface finish. Let's say that's our document complete and that's all we wanted to do. As I say, a very basic, simple document. What I'm going to do is I'm going to create, I don't need to display these anymore. So I'm going to delete these. I haven't deleted them from the document, I've just removed them, hidden them if you like. And all I'm going to do is just shrink this down and tidy this document up a little bit. And we'll change this over to landscape. And expand that. And there you have the document. Okay, once I've done that, all I have to do is save the document. So I'm going to say File, save the document as, and we'll just call it test. And save. Right, now we're ready to slot this document into our program. So I'm going to go back to Instrument. Okay, so what we're going to do is go back into our last measurement that we did, and we're going to edit that program. And you notice at the bottom of this menu here is the apply to apply documents. So here you can see the analysis. What we're going to do is apply a document, and we're going to apply a document called test. So if we browse, you see there's the test document, and we're going to apply that to this untitled document 6. Okay, what we're going to do now is we're going to run the program and test it. So before we do that, there are a couple of things that need to be sorted out. One is that we still have the points on the screen, and if I run this program, actually what it will do is it will stop because it will say you've already got those points. So I'm going to click on point number 4, and I'm going to go to the toolbox and I'm going to hit the word clear, and it will search for anything with the word clear in it. In this case, first of all, I've got clear data. I drag that across, put it in between steps 3 and 4. And then we've also got our clear all PCS point. And again, I'm going to drag that in and put it between steps 4 and 5. And we're ready now to run our program. So I'm just going to move this out of the way a little bit. I'm just going to slide along so we've got our run button just here, and we're maximising the screen. And I'll just put it into 3D mode so you can get a view of what's happening here. Let's turn the 3D view to this angle, and we'll zoom right into the path. And now we're ready to run the program. Press run and off we go. And there we have our result. And that completes our basic program.